To further explore our idea of a function that works as a black box, where it takes, say, an input x and gives an output f of x, imagine this alternative scenario. We want to find the average winter temperature at a point of the map of Ontario below. For instance, here's Kingston over here, and imagine the very different average winter temperature up here in the northern corner of Ontario. How much information would we need to specify to be able to output, to get a value back for that particular point? Well, if we knew the name of the town, in some sense it's a straightforward thing. If we know the name Kingston, then we can find out the average temperature by looking at a table. But that doesn't cover the whole range of values in between towns. If we pick an arbitrary point somewhere in the middle here and ask ourselves, how do we know the temperature there? Well, most of you will probably naturally gravitate towards the idea of the latitude and the longitude. So the latitude is the north-south, the longitude is the east-west. And if we specify both of those pieces of information, then we get a single location on the map. If we know our XY location, our latitude and longitude, we know exactly where we are on a map. Well, that gives us the answer, in fact, of how much information we need to specify to get a temperature back out, is that we need a latitude plus a longitude together to go into some temperature function, and that gives us the temperature at that point, at that latitude and longitude. More generally, or more typically for a math class in engineering sciences, we could imagine specifying two input variables and getting a single value back, which is a function of x and y. How is this different from our earlier models? Well, it's not enough to simply specify an x. Imagine going left to right is x here. If we just say we are at longitude 49, well, that doesn't tell us enough information to be able to identify the output, the average winter temperature, because we also need to know how far north we are. And likewise, knowing how far north we are doesn't let us compute the average temperature until you say how far east and west you are. So here, there's a very natural definition of a function with two input variables and a single output variable. And it's still a function. If we know x and y, there's at most one average winter temperature. So it seems to obey all the definitions of a function. It just has a different form when we're constructing it. More information is required in the input than we've seen before. So to recapture that idea, we would have a pair of values, x, y, that would go into a black box, and that would be our temperature function. And on the output would be the single value xy. So this is a single value, but the input must be a pair of values. Going back to nomenclature, if we think about the domain is tied to the input, the range of possible inputs, and the range is the range of possible outputs. And for these particular scenarios, the input values here could be defined several different ways, but one idea would be all the xy's that are on the map. If we only have temperature information for Ontario, then the only inputs that make sense are xy's that are in the map of Ontario. When it comes to the range, here it gets a little messy, and it's not usually a major concern for us right now. Just keep in mind what the challenges might be. We could define the range as what possible temperatures we could reach. So that could be potentially all real numbers in some sense. Or if we want to get fussier and say it's a temperature, it's all possible Celsius temperatures. But that would exclude everything below 0 Kelvin, or it might be only the temperatures in Ontario. In other words, there's different ways to define the possible range of a function like this, and until we know the context of the question, it doesn't make as much sense. The input tends to be much more clearly laid out in a problem. If we have a map, only the things on the map make sense. If we have a function, say like tan of x, we know already that there's some values where tan of x is not defined, that's not in the domain. So the domain tends to explain itself or define itself without needing to know as much context. So we'll worry about the domain. Range is just an important term to have in the back of your mind. When you're looking at functions, it comes up in common parlance, but just know that it's not going to be something we spend a lot of time looking at. Now, geography is a natural way to get functions of several variables where we have multiple inputs, but just one output. What other kinds of functions come to mind with that? Well, if we have an XY location on a map, of course, we can talk about a very natural thing, cartographic maps. We can talk about the height of the surface above that. So how tall is this mountain at this particular location? We can certainly diversify farther than that, though. Think of a few examples if you can at the moment. What if we talk about a couple and we have spouse A and we have spouse B? What are the kind of things we might want to study in an economic sense about that? Well, we might want to have family income. So if we have all possible couples in Canada, we might be able to output a single value for each of those couples, which is the family income. If we want to go even larger scale in economics, if you look at the S&P 500, well, that is literally 500 stocks. And the S&P 500 takes the price of those 500 stocks and produces an index value from that. So we have 500 inputs, in fact, for this, generating a single value back out. So not only are multi-input functions with a single output common, they are not limited in any way, shape, or form to simply two variables. Many things, in fact, if we talk about graphical images, for instance, any photo taken with a camera, this could be 20 million pixels, and we can quantify that with some other properties such as the lightness, general lightness overall. Or if we allow category labels, we might have a label that says it's a picture of some kind of object. So these input scales can be monstrous. Another, of course, would be actually DNA and mapping that to some kind of output about an individual. And of course, that would be billions of inputs. So lots of functions are going to have multiple inputs with just a single output value. Of course, none of that's really helping us with our physics side of things. That's what we're going to explore in the next video.